Welcome everybody to the Spring 2022 lecture series of the School of Architecture and Design at New York Institute of Technology. I'm Alessandro Melis, the chair of the lectures and events to the Spring 2022 lectures and event committee, and would like to welcome everybody on behalf of our Dean, Maria Perbellini. The topic of our lecture series this year is community, and we intend this as community beyond borders. We think this aspect will be relevant, especially these days. This will offer opportunity to discuss and debate how application of architecture, design, digital arts, and urbanism in this context can achieve a positive impact, innovate, and be of benefit to communities and society. Thanks to the committee members and to Susan Sterbank for the organization of the series. Today, I would like to particularly thank Tom Verebes for having conceived and curated this special and excellent series of events linked to the courses coordinating with outstanding guests like the one we have the pleasure to meet today, Robert Harrison. Robert, we are delighted to have you here today. Thank you, Tom, and thank you to our distinguished guest. I leave the floor to you, Tom, for the introduction of the guest and the topic of the lecture.
Thank you very much, Alessandro, for your welcome on behalf of Dean Perbellini. Good afternoon to our school community and the public joining us today. This presentation and student-led interview is part of a series of 6 public presentations and interviews within, as Alessandro, you mentioned, my graduate research seminar, Beyond the Envelope, in the Master of Architecture program. I'd like to thank Dean Perbellini and the Lectures and Events Committee for supporting the inclusion of these presentation and interview events as embedded into our Spring 2022 Lectures and Events series. I'd like to also clarify a little the credit to the idea of this seminar to Director Professor David Diamond, who came up with the idea in summer 2020 during COVID, and for supporting a second run. And it was born out of a context of teaching and learning in 2020 when the classroom and all public events had a life here on Zoom, configuring a format of short presentations by the architect of a recent important architectural project, focusing primarily on the design, production, construction, and life of one single building, followed by a student-led interview, today by MArch students Dalton Lackey and Noah Seaback. It's a pleasure to welcome this afternoon Robert Harrison, Senior Partner of Foster & Partners, who had led the project in focus today, St. Mary Axe, also known as the Swiss Re Tower, completed in London in 2004. Also, affectionately and popularly known as the Gherkin. For those, here we are in the US, so for those who don't know, a gherkin is the word for a pickle in British English, and due to the building's general shape, that of a pickle, this nickname and its associated building figure is instantly recognizable. And the name, the gherkin, has been embedded into popular imagination through the imprint of this figure onto the skyline of the City of London. While those of us in some of the leading academic contexts of the 1990s were busy generating and theorizing three-dimensional curved surfaces and volumes, or blobs, as we called them, concurrently Foster & Partners were busy building several examples of curvilinear building envelopes and roof enclosures. Although known and loved widely for its smoothly rounded form and its striking urban presence, made possible by the continuous digrid skin, the gherkin's contribution is perhaps more pronounced with respect to the development of ecological thinking and its unique diagram of passive cooling and ventilation. Testament to the value of what a building does rather than purely by its appearance, the architectural performance of the gherkin can be measured through its explicitly declared environmental responsibilities and contingencies. Internally, the scheme of 6 spiraling atria creates natural airflows which reduce energy use and cooling through natural ventilation. The gherkin demonstrates how technological innovation can establish new cultural and disciplinary norms as radical propositions become embedded into mainstream practice. As a benchmark in high-end office design, the gherkin is a great example of how architecture can take on symbolic value culturally, civically, and ecologically. We're grateful to Robert Harrison to join us today, to share your presentation, and to participate in a brief interview. As I mentioned, our presenter led the project from the late 90s until its completion in 2004. Robert Harrison studied architecture at Cardiff and Kingston Universities, graduating in 1995 after working at Building Design Partnership in London, where he was involved in a number of infrastructure, commercial, and leisure projects. He later joined Foster & Partners in 1995, initially based in the Glasgow office, working on the Scottish Exhibition and Conference Centre, where he was responsible for the building's external envelope. He returned to London in 1997 to work on the winning competition for the Gateshead Regional Music Centre and the reworking of JC Deco's UK headquarters in Brentford. From 1999 to 2004, he worked as the project architect on the Stirling Prize-winning headquarters for Swiss Re in the city in London, better known as the Gherkin, as we all know now, and the focus of today's presentation and interview. Following completion of the Swiss Re project, he led the design and construction of the Willis building at 51 Lime Street, also in the city, completed in 2007. He led teams on numerous projects in Auckland, Shanghai, Seoul, and during 2007-8, before relocating to Abu Dhabi in 2009 to oversee the construction team on a project for a central market. In 2010, he moved to Riyadh, Saudi Arabia, to run the site operations of 4 mixed-use projects at King Abdullah Financial District. Returning to London in 2011, Robert spent the next 7 years on projects in China and India, as diverse as the 7.5 million square foot CR City development and DJI headquarters in Shenzhen, Xiamen Airlines headquarters, Vantone Sunny World Center in Shanghai, and the Amaravati government complex in Andhra Pradesh. In 2018, his focus has been to develop projects in New York, Miami, and London for J. Safra Real Estate, several of which are now on site. He's lectured at the British Council for Offices, the City of London Festival, the Royal Institute of British Architects, Sponge Corporation of London, Chartered Institute of Builders, London First, and the Architectural Association. He was made a partner at Foster & Partners in 2006 and a senior partner in 2021. Please join me in welcoming Robert Harrison, senior partner of Foster & Partners.
Thank you very much, Tom. A very thorough introduction. Thank you for that. And welcome to all of you. It's very nice to join you this afternoon. To follow up on a part of your introduction, Tom, I'll talk for a little bit about the name of the Gherkin. It was originally used as a term of disparagement. It was picked up in the press at the time when the project was going through its planning phase. But it became so adopted, not by us and not by our client. In fact, we were pretty much instructed never to use the expression. So you won't find anybody on the team throughout its construction, and even during Swiss Re's subsequent ownership of it, ever referring to it as the Gherkin. But you can only fight against the tide for so long, and it has become so ubiquitously known. Everybody, you get into a cab and you just say you want to go to the Gherkin, they know exactly what you mean. If you were to say I want to go to 30 St Mary's, they'd probably scratch their head. So the name the Gherkin has become one now of endearment. It's a term of affection that's labelled for the building, and indeed it is now branded as such. So J. Safra Real Estate now own the building. They bought it back in 2014, and they saw no point in fighting against what everybody else terms it. So the whole building, the site, everything is now branded around the name the Gherkin, and we, after much therapy, have become quite used to calling it that as well. It did take quite some time. So I'm going to talk primarily about the building's envelope and its the way natural ventilation is employed within it. I have a few my own personal comments to make about that towards the end. It's been, what now, 18 years, 19 years, because the base building, the shell and core, was completed in 2003. So it's now 19 years since that time. And I've got my own
Yeah.
reflections on how the building's been used. Sure, I had someone then. I'll carry on. So primarily I'll talk about that, but I will there's certain anecdotes I think that would be pertinent, and a few of my own observations with the passage of time, with nearly a generation passing since the building was occupied for the first time. There's a top-down view of the building, and Tom, you talked about the using three-dimensional forms, or incorporating three-dimensional forms into architecture. It happened to the period at which this building was developed happened to strike a fairly rich vein of that in the practice. So there were a number of buildings around about this time where we were exploring, and it was a combination of having software that enabled us to model the forms that we were interested in. It was as well being able to schedule out, once we documented the job and once it had got to the stage of tendering, it was much easier for us to schedule that information to be able to deliver it to contractors so that they were able to understand it and they were able to break it down into buildable componentry, and not for that to be extortionate in terms of its cost. It just happened to catch a particular wave at that point in time in the late 1990s. You can see very much illustrated on the top-down view of it, the way all of the spirals come together, particularly up at the very top of the building. So not only does it have quite a zoomorphic form in its elevation, but particularly in its plan, particularly in the roof plan, you really see the references back to nature, the references back to objects such as pine cones, which were so crucial to us in the early form finding of the project. This was, believe it or not, this was the brief essentially that we had from Swiss Re, one of the shortest briefs we've ever had. And it was done deliberately in order for us to investigate and find out with them as our client what they wanted. So there were certain criteria that required, just in terms of area and in terms of their aspirations for it. But the one that's relevant to the conversation today is around its environmentally progressive design. And they deliberately used those words. They're deliberately a little nebulous and hard to pin down because, again, they weren't sure what was going to be possible. And they didn't want to dictate with a more prescriptive based building definition quite how many watts per square meter per person were required within the office space. So they left it as this loosely termed phrase, environmentally progressive design, for us to develop and investigate with them during the course of the design development of the project. The two triangles that you see here, the upward pointing and the inverted version, and the text that runs between them, is a shorthand for saying there are certain things that make a very, very big impact on the project, and things such as orientation, how we turn the building around when we first place it on the ground, if our site permits us that luxury. There are certain things that are well within our gift and are achievable for a relatively modest cost. As you go through more and more sophisticated systems, then the cost increases considerably. So by the time we get to very, very active systems, the cost of implementing those active systems are considerable. So the more we could do with the form of the building and with the orientation of the building, the more we got out of the performance of the building for a relatively modest impact, a modest financial impact. And one of the primary things that was available to us was the fact that the southwest corner, so the bottom left-hand corner of the screen, is the predominant wind direction. In London, in the UK generally, we get 60 to 70% of our wind comes from the southwest. The location of the site, we happen to have a reasonably open space towards the southwest corner, which meant that we were going to get towards where we eventually placed the entrance, we were going to be getting the predominant wind direction running through. There were a number of requirements that came through from the local authority as well. Without delving too much into the history, the site was, the previous building on the site completely filled the whole of the site boundary. So up to the edges, north and south, where those dark black boundary lines are drawn. The site was demolished by predominantly demolished by a bomb in 1992, and then it was completely cleared in 1995. And one of the stipulations from the local authority was that whatever form of building went back on the site, it had to have a more modest footprint. It had to have a smaller ground floor where it hit the ground, where it hit the site, in order to create a plaza around it. London at the time, and it's still the case for a lot of developments, and particularly in the City of London, there's not an awful lot of public space. If you want to go out at lunchtime and you want to find open spaces, there are more of them because they're being mandated on newer schemes, but you were pretty much limited to the churchyards that dot around the city. So the local authority was keen that anything that we put on this site had a plaza around it, so that people could take advantage of it and use that. So at a first stipulation from them about the size of the building's footprint where it hit the ground. Then there are height limitations and height restrictions. This is going back almost 25 years now from when we started it in 1998. And the skyline of London was very, very different to how it looks now, particularly in the square mile in the financial centre of London. So there were a lot of restrictions on height. There was no way we were ever going to take this to perhaps the height that we might have originally enjoyed. So there were a number of external factors bearing upon us, together with the brief that Swiss Re provided for us. So taking those as a cue, if we were going to pinch the building in at the base, then there was a kind of a logic to the form being squashed and condensed on those lower levels. Because there's a need for quite a significant amount of office space, and one of the primary drivers of office space is ensuring that people are able to get to their desk in as quick and efficient a manner as possible, particularly in the morning up peak. The need to provide large amounts of floor plate within readily accessible and quickly accessible lift traffic was another primary importance. So having larger floor plates and with those bigger floor plates having the advantage of excellent views, again in London, and it's even the case now, once you get up to about 8 stories, the predominant mass of building stock in London is up to about 8 stories tall. There are then the pinpoints that go up higher than that, but you get excellent views once you get up to about 8 floors high. Even in the City of London, the views are still pretty good at that height. So it made sense for floors to be wider, larger, bigger floor plates, where they were quick and easy to access via the lifts, but also where you were then got fantastic views. Then the brief for the top of the building space was very different. Swiss Re wanted their entertainment floors to be up there. At the time of starting the project, they envisaged taking at least 3/4 of the building. In the end, they only took half, but it was really going to be more or less all theirs, and they had very specific requirements about how they entertained their clients and how they entertained their own staff. And that's what fed into the brief for the top of the building. It was much more modest in size compared to typical office floor plates. So again, setting the agenda for what the top of the building form was going to be like, putting all those considerations together, it helped to set up this diagram that you can see in piecemeal fashion here. I want to just show you a clip now that will run for about a minute, and it shows the same volume, 500,000 square feet extrapolated across 4-meter high floor plates, arranged differently on the site. So if we were to have completely filled the site with that volume, then as we were required to pull the building in slightly, then to deform the shape of it into something that's more recognizable as the building. I'll come on to talk about some of the reasons for that later on. Then the splicing of the atria around the building. Again, I'll talk about a number of those and why they're positioned where they were a little later. The twist that occurs from one floor to the next. And then the layering, you have a layer for the main structure of the building, and then there's a finer grain, a finer layer that's overlaid on top of that for the exterior envelope, for the cladding of the building. But that kind of puts most of the main thoughts that we'd had together into one illustration. Part of the reason for curving the form of the building, a lot of it is to do with its environmental response, which I'll come on to shortly, but the other is to do with the perception, its perceived bulk. There's still a adjacent building to it. There's a planning permission for a much, much taller scheme on the site, but the existing building, which was existing at the time that we constructed this, it's not dissimilar in terms of its overall area, its floor plate size, but it's square in form. And if you lay a square on top of the circumscribed circle that we have for the plan of the Gherkin, and then perceptually how that appears, because with a cylindrical form or a slightly deformed cylinder, there's no edge, there's no corner, there's no definite side to the building that you can ever say, that's the actual corner of it. Your eye is always chasing the edge of the building around. And again, by altering the building's vertical elevation so that it's curved, pinched in at the bottom, widens and goes to a smaller form up at the top. The same thing when you're looking up at the building, there's never a point where you can say, that's the edge of the Gherkin. It's always kind of moving away, stepping away from you. And perceptually, it makes the form, the bulk of the building. We have some pretty significant floor plates. They're up to about 20,000 square feet on the larger floors. The perceived mass of the building is considerably reduced because of its form. To illustrate that in plan and how that then affects the amount of daylight penetration that we get deep into the floor plate. A traditional center core building, obviously excellent light all around the outside of it, but there's this submarine space adjacent to the core where very little natural light ever gets to permeate. Just doing a purely cylindrical version of that, or a circumscribed circle within that, doesn't really improve the situation. It just puts it into a different form. You still have this space around the core, which is less attractive, less well lit, and with less access to views. The trick that was employed on the Gherkin was to then cut a series of light wells in, and in the end we decided upon 6 light wells. So 6 light wells cut right back to the circulation route of the core, and that provides light, provides daylight much deeper into the floor plan, so that pretty much all of the available floor plate gets good access to daylight, and most crucially, really good access to views. It really doesn't matter. Even if you're right back, you still get these glancing views down the atrium, or correspondingly back up the atrium to see the sky, or down towards the ground. So that sense of having the city around you, not just looking out to the horizon, but being able to see down towards the ground, a crucial part of people feeling more grounded within their workplace. This was Norman's sketch that he did quite early on that kind of pulls all of that together, the idea of these light wells. And in the end, we rotated the light wells for it helped drive the natural ventilation story of the building a little more. But this kind of captures everything in this one sketch of his. Illustrated again in one of the illustrations that we did for the building, or a zoom in of the illustration that you can see here. We had originally wanted the light well edges, the balcony edges, to be landscaped. We battled for a long time. I think the passage of time, I can safely say this. We were convinced we could have got a a landscape strategy to work within the building that didn't require a significant amount of maintenance. We were very careful about the plant selection. We made sure that it was different on different sides of the building. On the north side of the building, we had very different, with much lower light levels, we had very different planting there. Where it was to the south and to the southwest, and where you get more direct ventilation, we had a different planting strategy there. I would say that the echo of this now happens in the lobby of the building. We've got to redo the lobby over the last couple of years, and we have introduced trees into the lobby of the building. So whilst we haven't managed it within the office spaces, we did at last, after some 20 years, manage to get some landscape and greenery, significant landscape and greenery, back into the building. That's a view looking up one of the light wells, and just to give you an idea of how it stacks up. The light wells, there's 6 of them per floor, and they are 6 stories high. So they occur in these 6-story stacks as you move up through the building. That's a view from one of the lower levels. I think that's level 10, looking up to the underside of level 16. The light well itself is a 20-degree arc, which is then placed against a 40-degree arc of office accommodation. So in total, there's then a 60-degree portion, which is then arrayed around the rest of the floor plate 6 times. And that's essentially how it's built up. What then happens is each floor, as it goes up,
Robert, you're muted. We're not sure why you're muted. You need to unmute, please.
being all right here.
Yeah, we're good.
Is that okay?
You're back.
There seemed to be an auto prompt came up on screen. So if it happens again, I think it will just stay for 30 seconds and then disappear. Hopefully not. I was talking about the way the light well is a 20-degree portion, the office is a 40-degree portion. So altogether, that's a 60-degree portion, which is then arrayed 6 times to give you the circumference of the building. Each time it goes up 1 story, it rotates around 5 degrees, which is what gives this shift that you see when you're looking up, or correspondingly, that's the downward view of it. The edge that you can see at the bottom of the screen, there's always a balcony on the leading edge of the atrium, and there's always a full height office on the trailing edge of the atrium. So the offices are placed on the back edge of the atrium, and so that they don't interrupt the rest of the individual floor plate section, so that the floor plate can remain as open plan. In many cases, they don't have any partitioning on that side. They just leave it as a completely open space. The reason for the 5-degree shift, it helped to increase the natural ventilation flow across the floor. This is a view, this is actually over the entrance space, so you can see right down at the bottom, that's the glass floor, which looks down onto the arrival, onto the entrance floor. It's actually the view facing southwest. And because, as I mentioned slightly earlier, the predominant weather comes from the southwest, so the majority of our wind comes in this way. And essentially what happens, wind, you got positive pressure against the southwest edge of the building. If we open the windows on that side, they will start to flow through into the floor plate. If we then open the windows at the back side of the building, on the northeast side of the building, there's the pressure differential between the 2 sides, and effectively the air just flows across the floor plate. What we also wanted to do was to ensure that it moved up the light wells so that it could then be collected up at the top and then extracted. And we found that by twisting the light wells, it just helped a small amount to drive that upward movement of the air. It also makes for the fact that you get these great architectural spaces within the building. They're far more interesting that they are staggered and spaced across rather than just vertical slots that would have occurred. The wind flow around the building also meant that the downdraft that's produced from a 40-story building was considerably less than had it been an orthogonal rectilinear building. With an orthogonal building, about 2/3 of the wind that hits the face of the building that faces the predominant wind direction, about 2/3 of that wind is deflected down towards the ground. But with a more aerodynamic form, more of that wind just flows naturally around the building. So we have only about 1/3 of that component that comes down to the ground. So for pedestrian comfort in moving around the plaza, it was far better conditions as a result of the form. It may surprise you to know that the vast majority of our initial exploration of the form of the building was done through models, physical models, as opposed to computer modeling. So we produced dozens and dozens of these models here, and each one was perhaps 2 feet tall. So each one was it was about a 1 to 250 scale that we were working to. The scale was actually derived by, and you can see it in the one that's in the middle there, that little blue circle up at the top of it. That's actually a piece of our printer rolls. So the rolls that we used to do all of our printing on, like a great big long toilet roll, that's what formed the structure for us to then pin the foam cuts. So all of these were just bits of foam board that we cut. We got very good at using these compass cutters. So like with a natural old-fashioned compass that you would use to draw circles in maths, exactly the same as that, but with a very long extension and a scalpel blade on the end of it. We got very adept at cutting foam board and then cutting into the foam board to consider whether we were doing triangular cuts, square cuts, trapezoidal cuts, whether they flowed in one direction, whether we had 4, 5, 6, 7 per floor, whether we changed it from bits one section to another. All of those were explored with these models. And only after we'd kind of gone through this exploration did we really then take it into CAD. So a vast amount was done with traditional model making, and it really was as rough and as sketchy as this. An awful lot of what you see of the project shows this incredibly slick, almost machine-like production for it, as though it all flowed through in a seamless way. But the first few months of it, it was all work like this. It was very scrappy, it was very sketchy, but it taught us an awful lot about how the whole thing would come together. And our client, Swiss Re, found this incredibly useful, understanding how the floor plates would stack, understanding the relationship between different floors, before all the practicalities of fire compartmentation, of structural grids, of office planning and furniture planning grids kind of came onto it. This was such a great way of developing those ideas in the first part, but it's often the unsung hero of the project. To talk a little bit more about the potential for natural ventilation, we worked closely with the client, but also with our environmental engineers to discover when it might be possible, when there might be the potential for natural ventilation. And it really boiled down to that zone in the yellow, sort of between about 12 degrees external temperature and 25 degrees external temperature. That was the sweet spot for us. So the possibility that you could naturally ventilate the building during that period. In the shoulders either side of it, in the winter times or the less clement times, you would need an element of heating to supplement the natural ventilation. And then at the other end of the scale, in the summertime, you would need an element of cooling in order to supplement the natural ventilation. But the plan was that for a period of time when the temperatures and when the wind conditions and when the precipitation was right, there was the opportunity for natural ventilation. And in terms of the final modeling of that, and we're still I had to be a little bit careful about this, but we still get a bit irked here. We still get a little bit annoyed that there's a vast amount of data that has been collected on the building. And we've been trying for a long time to get access to that, because we would actually love to know how well it has performed. So against the benchmarks that we were working to at the time, almost against the prescriptive requirements that we set for ourselves with our client, we'd love to know actually how it has performed. And it's something we're talking to the current owners about, and they're quite open to that, but we still haven't got the data on it. We'd love to know quite how well it does perform. But at the time, and you've got to bear in mind, this was going back to the late 1990s, the specification back then for a prestige high performance artificially ventilated office building, you were looking at about 350 kilowatt hours per square meter per person. We managed to, with our predictions, get that down to about 150. That's what the building performing optimally, we believe that's where it would sit, probably around about 140 kilowatt hours. Quite whether that's been achieved in practice, I don't know, and I couldn't give you the answer to it. I do hope one day we'll be able to, because I do hope one day we'll be able to get access to all that data. It's a little bit like, I always say it's a little bit like my relationship with a computer. I've got this thing on my desk which can do an enormous amount, and I just kind of scratch the surface of its capability. We feel that's the case with the building. It can do an awful lot. We just don't think it's been stressed. We don't think it's been put to its full potential use yet. And we're hoping with Safa Real Estate Group that we'll be really able to get to grips with that and help them to push the building on further. An awful lot of modelling was done, both CFD modelling, but traditional wind modelling as well, where we simulated the wind environment around the building in order to test different wind pressures to be sure whether it was practical and possible to open the windows, particularly higher up the building where the wind velocities are stronger. That was then corroborated with CFD modelling that was also done for it. And it's culminated in the building having this, and it reverts back to some of those very, very early forms of the building, the pine cone shape of the building. It's then, there's an even greater reinscription of that in the way that the building performs environmentally. It opens up like a pine cone does. When it's wet, it kind of closes down. In the summertime, it can open up and be used particularly for nighttime purging. During COVID, particularly the first summer, the 2020 summer, London was very hot for that first period. So May and June was incredibly good weather here, or incredibly sunny weather, whether you see that's good or not. It was incredibly sunny weather in London. The building was hardly occupied at all. So they weren't running the air conditioning. The offices weren't in operation. So the building was heating up enormously during the day because there was nothing running inside it. They then opened all the windows, particularly in the latter part of the afternoon, and kept them open during the evening. And the nighttime purging of the heat from the building was incredibly successful. And it went for weeks and weeks and weeks when we didn't have any rain at all and very, very warm weather. And they just left the windows open the whole time. And it made for quite comfortable conditions inside. So it vindicated the strategy we had. I just wish this was more often used now. But I'll just run this video for you, which will show you how that occurs. So a little bit of background on these windows. There are 6 light wells per floor. There are 4 opening windows per light well. So every single floor has 24 opening windows on it. And they work in this butterfly arrangement. So the actuators, there's a chain that actuates one upwards and one downwards. So you get this butterfly effect with them. So they work as a pair every 2 floors as you work your way up the spiral. And they're linked to sensors around the building. So when there's cleaning cradles out, obviously the windows aren't going to open. When the external weather conditions aren't right, they're not going to open. But at the right periods of time, we believe it's, and it was kind of proved during COVID with the purging, it was proved that they're very effective at doing the job that they were initially intended. Just to finish off with a few illustrations of the building so that you can kind of see it more in all its glory. The spirals, which are the light wells of the building, very clearly marked against the whiter elements of the office accommodation. So these, the stripes that you see, these spiral stripes that you see, they're an identifying feature in the long distance views. When you get up close to them, though, that's where you start to see the functioning of the space much more. You start to understand the way the floor plates are arranged. It's a very readable, very understandable architecture. That's the entrance space with the glass floor over the top of the entrance space. That's the floor that you saw, the downward view that I had earlier, looking down the light well. That is the floor that you saw at the bottom of that view. It's an older shot of the lobby. We've now completely redone it and made it a lot more personable and a lot more human scale within there. And then a final shot looking from the southwest corner of the building, that very open section in the southwest corner. Final slide coming up is a time lapse. I apologize, it's a webcam from the 1990s, so you have to forgive the level of resolution. It's not quite the 4K that we would like to have these days, but nevertheless I still love looking at it, and it gives you in 30 seconds what was 3 years of construction. There you go. Thank you.
Thank you very much, Robert, for your really wonderful presentation. It's really a thrill to see so much more than what might be published, and it really is a testament that inviting the architect in is a really special experience for us, for our students, and for the public here. I'd like to introduce now, as part of the format for these for this series, a student-led interview after the presentation by the architect of a single building. So I'd like to introduce Dalton Lackey and Noah Seaback.
Hello, my name is Noah Seaback.
And I'm Dalton Lackey.
We would like to thank you.
Hi both.
We'd like to thank you for your insightful and engaging presentation. 30 St. Mary Axe, or as popularly known as the Gherkin, is situated within the historical context of London, the city of London. The project has rightly been praised for its achievements in creating a new benchmark for passive cooling, ventilation, and energy reduction. Within the ecological and technological context of the turn of the century, we also believe the building had a substantial contribution to the advancement of banking, finance, and other professional office building space design. Were there any contradictions between the ambitions of radical approach and the responsibilities of responsible environmental practices of this building's design in terms of the environmental innovations and the expectations of a landmark headquarters located in the financial district?
You raise a very good point, and that is that had this been a commercial development, a purely commercial development, had it not been an owner occupier, had it not been Swiss Re who were ultimately occupying the vast majority of the building. So if we were doing this as a speculative development, or if we were doing this as a building for a developer who was just maybe had a different anchor tenant in mind, but was not an owner occupier, it would have been impossible to achieve the goals that we wanted to. The efficiency of this building, it's good, but you'll never compare it to a more traditional rectilinear, more formulaic office building. It just don't stack up. We cut out 6 triangles out of our floor plate on every single floor all the way up. There's very few. You have to have a very dedicated client who's prepared to sacrifice that. Now, because Swiss Re, they were in about 6 different offices across London at the time, or across the city at the time. But their business, they're a reinsurance company, and the vast amount of their general day-to-day work is done through Lloyd's of London, and it involved at the time in the early 2000s, perhaps for at least a decade after that, it involved them effectively going to the marketplace of Lloyd's, and they would carry bundles of paper, and it was paper, actual paper. They just, that was what their contracts were. They'd go to the marketplace, they'd do whatever they do in the reinsurance world, but it was all traded out of Lloyd's, and Lloyd's is 100 yards away from the Gherkin. So locationally, it was perfect for them. But and it was perfect in terms of having a site that was big enough to agglomerate all of their other offices together into one space. But they had a very particular requirement with their brief for an environmentally progressive design, was to make a statement about who they were and to get their name more broadly. There's no better bit of advertising than this building for them. It was the perfect symbol for them. So they were prepared to sacrifice many things that other developers simply wouldn't have done. And they were prepared to sacrifice efficiency within the building, pure efficiency, because they felt that what was being achieved made for a far better working environment, and it made for a better statement about them as a company, about what their ambitions were. But you raise a very good point. Had this been for somebody else, had this been for a different financial institution, we would never have, the building wouldn't have looked anything like this form. There's not a way of kind of fitting an efficient, super efficient floor plate and a super efficient office design into it. It's efficient to a point, and it works really well for them, but it required a very particular client. We were extremely lucky to have them.
Thank you.
So in our seminar, we're looking at 6 outstanding built projects, analyzed in relation to a set of 6 different themes. This week's theme was climate and energy, with the Gherkin obviously exemplifying this concept. The building's been celebrated for its passive cooling strategies. So in our analysis, we wondered, how has the all-glass facade performed with respect to heat loss in winter months, and how passive heat gain may have helped to reduce energy consumption for heating in winter?
The skin of the building, which I didn't dwell on in my presentation, but to give you a little more information on that, in the office portion of the building, so the 40-degree section of the office component, there's a double skin facade, a very deep double skin facade, and it's internally ventilated. We tend here, it's not unusual now for us to have double skin facades, most of our projects do, but they tend to be externally ventilated. They're easier to maintain, they take up less of the overall volume of the building, so in terms of build efficiency, they're better. But when you've got a curving building and you're putting a floor plate across to it, you always come to a point where it's either like this or it's like this. And when you want vertical bits like wall surfaces and glass screens to go up next to it, you end up with this triangular zone that's created, which started the thinking about why it should be an internally ventilated system as opposed to externally ventilated. But the use of natural ventilation, so opening up the light well portion, the 20-degree section, so that's where the air, the natural air comes in, then that feeds and flows across the floor plate due to the pressure differential from front to back. As it then moves across the floor plate, we needed to be able to use that cooling air that comes through in combination with it's very rarely it works in full natural ventilation mode. It's almost always in mixed mode. So you've got a combination of air conditioning working with the natural ventilation coming across. The double skin facade allowed us to have a buffer zone between the external wall, which in summertime gets very hot, and in wintertime gets very cold in comparison to, let's call it a 20-degree office temperature inside. We had a larger zone to deal with that thermal buffer, and we were able to use that zone to effectively flush office air into the space in order to temper it. So if it was, I'll make the maths simple for me, you'd be far better at this than me, but to make the maths easy for me to understand, if it's 0 degrees, and sorry, I'm in centigrade here, so I wouldn't be able to work this across to Fahrenheit. If it's 0 degrees outside and it's 20 degrees in the office, you've got a pressure differential across there of 10 degrees. But if you can take a 20-degree air out of the office, flush it through the void at the edge, you're warming, you're tempering that space. So you then have to provide less heating into it. The reverse in summertime, simplistically, the reverse in summertime, you've got maybe 30-degree air on the surface, probably more on actual surface temperature. But let's say it's 30 degrees outside, 20 degrees inside. Again, you can use your internal air to help flush that space in order to reduce the comparative cooling load. What the natural ventilation does is helps to bring in, this is why when it's super hot outside, you can't use it. When it's very cold outside, you can't use it. But in the temperate conditions, you're bringing air in. Not only does it help provide reasonable temperature air into the office space, the really significant difference is it's natural, and you're increasing your air changes from maybe 8 air changes an hour, which a ventilated system would give you. You're up to dozens of air changes per hour. So it just feels a much fresher environment. And we found in the tests that we have been able to do, people will accept a higher, or they'll accept something outside of the normal range that you would expect in an office building, which is kind of typically set here in the UK at 22 degrees. So I suppose that's 70, low 70s Fahrenheit. And you'll find that a developer will stipulate in the base building definition that you get in your brief, it's got to stay within 4 degrees of that. So 70 up to 74, or for us, it's got to be 21 to 23 degrees. That's with a typical mechanical system, approximately 8 air changes an hour. It's enough, but it still feels a little bit stuffy. If you've instead got dozens of air changes an hour, people will accept, and it's fresh air that's coming through rather than constantly filtered air that's coming through. People will accept a wider variation in temperature. So they'll accept it going down to 19 degrees, or what's that, kind of 60, 66, 68 degrees. They'll accept it going up to kind of 78 degrees because the airflow is greater and it's fresher air that's coming in. And it's very difficult to persuade people of that. Even when you've got the data to prove it, it's still very difficult to go back to a developer with that. But we try on our projects to persuade them of that. It's still quite a difficult ask. But that's the double skin ventilation system, or the double skin facade that we had. It really helped with that internal flushing. So using the exhaust air to kind of temper what was happening so that we could reduce the air conditioning load or the heating load inside.
That's a great answer. Thank you. So we were also wondering, how do you think the building's energy performance may have been affected by climate change and rising global temperatures since the completion?
I alluded to it when I explained on those last few slides. When the building's used for nighttime purging, so when you just open the windows in order to just let the whole thing cool down, that has proved to be very effective, and was proved that they hadn't used it for that. They tended to use it, as I've explained a minute ago, about ventilating the office space when the office space is occupied, but its ability to cool the building down in the evening when nobody's about, and that really was vindicated during COVID. And with generally increased temperatures that we get, whatever the temperature increase is across the 20 odd years since it has been built, that can only be a good sign that There's generally more heat in the building. The heat rejection plant is no bigger than it was, and it's contained up in the top of the building as well. It's pretty modest in terms of the volume that it occupies at the top of the space. So that it's not as though there's a lot of space where you can suddenly stick a whole load more chillers and other heat rejection. So we have to make sure that it can become more efficient. We've just got to make sure we do whatever we can to let the building do it naturally, do it itself, rather than having to rely on ever more expensive and ever more costly mechanical means to do it. And with temperatures rising as they inevitably are, I really hope it gets used much more. It's one of our, I suppose, biggest disappointments is that we don't feel the building is as extensively used, as the systems in the building aren't as extensively used as they can be. It could be an awful lot more sophisticatedly employed. And we hope that will be the case in the future. Office environment's changing quite a bit, and we hope with that change will come the chance to put those measures in place on the Gherkin.
And how were environmental simulations used to aid the decision-making process during the design of the building? And what do you recall about initial testing or experimentation for that ventilation system with those systems of the time?
The two diagrams that I showed, there's one was the photo of the wind tunnel test in Toronto. It's RWDI's test center in Toronto. And that was as rudimentary as I think it was a 1 to 400 scale model of the building. It had a whole series of little pressure sensors inside it, so you could measure wind pressure. A lot of that was actually done for the cladding to make sure that we knew what the specification requirement was for the glazing, but also gives you data on, well, what sort of wind pressures are we going to be getting there, and is it practical to open a window when we've got those degrees of pressure. So it was done in the wind tunnel, but then a lot of the CFD testing by Hilson Moran, who were our environmental and mechanical engineers at the time, and they kind of pioneered that work with us, and it was across a number of the projects that we were doing at the time, but particularly so here. And it's what led to things such as the twisting of the atrium. We would never have done that had they not shown with their CFD analysis. This actually helped to push the incoming air. It helped to get the flow to work more effectively across the office floor plate if there was a degree of twist to it. We always hoped that would be the case. It made for much better architectural spaces inside, but that was an aesthetic response from us. It's nice that it actually then was vindicated through the environmental performance of the building as well. So CFD is crucial to us, and it's both internally, but also the flow of the flow of the air around the building. I mentioned about the downdraft that you get. Their simulation was able to show how much better pedestrian comfort was because of the building having the sort of more slippy form that it has. So crucial to it. It's come on obviously an enormous amount since then, but it was kind of early days of CFD analysis. Played a crucial role in several of the big decisions that were made.
Thank you.
Significant buildings, when they capture the public's imagination, become recognized as landmarks. We discussed how the Gherkin had been driven and shaped by the innovations in passive cooling and in ventilation. However, various publications on the Gherkin have declared its instant recognizability, more likely due to its distinct form and materiality of the project. Our next question addresses the notion of an architectural icon, a topic of debate for some time in architecture. Can you summarize your views on what makes this project instantly recognizable, and in retrospect, what do you believe to be the attributes of the project that contributed to having become a affectionate part of the public's imagination?
It looks very distinct from most office buildings. That's a great help. And again, you have to cast your mind back, or you have to look back at photographs of what London was like back in the 1990s. It certainly didn't have the shape of buildings that the city certainly has now, where there's quite a lot of interestingly formed, interestingly shaped buildings. Didn't have any of that. It was rectilinear buildings, good quality, 1960s, 1970s, early 1980s buildings, but they were all of a form, predominantly rectilinear in form. So the building naturally is a very distinct from all of them. It's still very distinct, even amongst the different shaped buildings that have now been built. It's still a very distinctive form. What we wanted to ensure, and this was with the approval of Historic England at the time, who are still they're now they were English heritage at the time, and now Historic England. They're still the kind of arbiters of London's heritage, or the UK's heritage, not just London's. But they were very encouraging about the elegance of the building. Earlier versions had the building's 180 meters, so 600 feet. Earlier versions were more like 120 to 150, so it was sort of 400 to 450 feet tall. Still had the same amount of area in it, 500,000 square feet. So volumetrically, it was a much more condensed, squashed form. So the original inspiration for it was a Fabergé egg, or one of the earlier reference points was a Fabergé egg. So it was more that kind of egg shape rather than the sleeker profile that it now has. Through their encouragement, the building became taller because it was felt that it was a more elegant form. It was also one of the determinants that we had was that the building could be read differently at different scales. So your context, the context around the building is different depending at what point you're viewing it at. If you're many miles away and you're looking back across at the City of London, what you're really looking at is more the silhouette of the building, but you also see the form of the primary structure. So the primary structure is on a 20-degree grid, and the diamonds that you see, those diamonds are 4 stories high from the tip to the tail. They're 4 stories tall, and they're deliberately painted white, whereas the horizontal elements within that, which at a distance you don't see because they kind of disappear, they're painted a very, very, very dark blue. So what you read from a distance is that 4-story high diamonds patterned around the building, and you see the silhouette and the form of it. That's what your longer distance context is. As you get closer to it, you start to read more of the detail of the building. And then that debate about when does it change scale, at what point when you get closer to it do you start to read the degree of finesse in the architecture, that was something we all debated a lot. And it's ultimately why the cladding grid is arranged as it is on a 5-degree module, and the cladding grid, although they're diamond panels, they span floor to floor. So we have a triangle top to bottom. You read a very different scale to it when you get closer to the building, and then when you get right up to it, you're starting to see all the detail. But that notion of an icon, yes, we were together with our client, we wanted to create something that was very memorable on the skyline of London. The way it was finally executed, with the input of a whole range of different people, including heritage lobbies, I think all contributed to a much better and more graceful form than we might originally have had.
So kind of a quick follow-up on the it being like an icon. Since its completion, do you believe that the insertion of an icon in a historical context welcomed the multiplicity of icons, making the district more open to that type of architecture and development?
I would agree that it did. If you now look at the skyline of the City of London, it is peppered with many different shaped buildings, and they're in quite a contrast. If you compare the City of London against Canary Wharf, it's quite a distinct alteration to the morphology. Down in Canary Wharf, it's a little bit more like, say, downtown Toronto. It has that kind of look and form to it. There's more of a uniformity to it. The city prides itself on having very differently shaped buildings, and the city as an authority, as the local authority, have been keen to push that. I won't make comment on my personal opinion of some of those buildings, but that's an aesthetic that they have. That is a desire that the City of London has. They want those buildings to have a very distinct individual personality, and their view is that as an agglomeration, as a accumulation of buildings together, that's what makes the City of London great. The fact that there is this distinction happening between them. They together form a cluster, and the cluster is the cohesive piece, and that's the uniform thing, this cluster of buildings. But within that cluster, they want the variety. They want to make sure that is very different from one building to another.
So in many respects, 30 St. Mary Acts project was ahead of its time because environmental building technology and building codes and regulations have changed in the last 25 years. If you were to design this project now in respect to passive environmental strategies, what would you do differently, if anything?
I'm not sure. The building kind of it met the zeitgeist. It was right for its time. If we're given the site again, we wouldn't end up with the same thing. It'd be a different thing. If you had a different client, it would be a different, an entirely different project. It's of its time, and it's of the people that took part in it, in its creation. If we did it all again, who knows? I think it'd be fundamentally different.
Okay, so urbanization, building construction, and energy use all have immense impact on the natural environment and serve to accelerate climate change. In terms of our collective ecological responsibilities, what is the future of architecture and what needs to change?
One of the debates that we're having here in our practice, and I know pretty much everybody else is as well, the initial response to a commission, the initial response to our brief from a client was always, what's the new building that we can put there? What's it look like? How does it respond to our clients' requirements? The first question we ask ourselves now on every project is, what element of reuse is there? Particularly in urban settings, how can we reuse fabric that exists on the site? And that's front and center, a sea change in what's happened previously. So whenever we work within particularly in an urban environment, that's the very first thing we'll ask of ourselves, is the very first thing we ask of our clients. More and more clients now have that uppermost in their mind, because they know that the people they need to persuade, the planning authorities, the local authorities, the planning committees, that's going to be one of their primary concerns as well. The more you can reuse, the more you don't have to demolish and take away, the better the overall energy performance of the entire estate and project will be. That's how that's the shift I've seen, and I can only assume that's going to accelerate still further.
I think that's it.
Great.
Appreciate it. Thank you so
very
much for your
much.
time.
Very
Yeah.
thorough.
Thank you very much,
Thank you.
Robert. We're really grateful for the time that you've taken to give your wonderful presentation, and especially also to participate in a student-led interview. Thank you very much.
My pleasure.
Greatly
I should at the start have said that Grant very much wanted to be here, but unfortunately he's contracted COVID at the beginning of the week. So he is having to isolate at home at the moment, but he does give his apologies.
Well, we wish him a speedy recovery. This is really
Thank you. Yeah.
those things in the 2020s that unfortunately is getting in the way of everything. But we're glad that you're healthy and we're able to participate today. Thank you.
Thank you. Thanks. Well, it was a pleasure meeting you all today. And thank you for your questions. They were thorough. They're very thoughtful, and I think they look quite quite pertinently to the future that's ahead of all of us. How can we make sure that our involvement in our projects are as environmentally progressive as they can be? That phrase, I think, that our client gave us from the start of the Gherkin, I think still holds true now more than pretty well a generation later.
Absolutely. Foster and Partners has certainly been one of the absolutely one of the leaders in meeting some of the environmental challenges that we face over the last 20 years or so. And we look forward to seeing further projects that advance these ideas.
Thank you.
Thanks.
Okay, thank you, everybody.
Thank you.
Bye-bye.